Good evening. Welcome back. I know I already released a video today at about 8 o'clock. It is now after midnight, so technically I left it yesterday, but I just read an article and I decided that we're going to talk about it because it's put out by Newsweek, but it's got everything to do with one of my favorite franchises that even though some people say there are four movies, there are only three. The original, and then two more after that, and then 10 years, 20 years later, they released another, and it was horrible. The name of the article is Do We Live in the Matrix? Physicists finally have an answer. I'm going to read this to you, and then I'll give you my thoughts afterwards. And by the way, I only understood like less than half of this, but we're going to read the whole thing anyway. Anyway, here we go. You can stop looking for glitches in the Matrix. It's finally been proven that our universe is not merely a simulation running on some powerful alien civilization's supercomputer. An international team of researchers used a combination of logic and physics to prove that the fundamental nature of reality means that it could never be simulated, no matter how hard one tried. This idea that once thought to lie beyond the reach of scientific inquiry, said paper author and physicist Professor Mir Fazil of the University of British Columbia in a statement. However, our recent research has demonstrated that it can be, in fact, scientifically addressed. Key to the team's determination is a cutting edge physical theory known as quantum gravity, which, as the name might suggest, attempts to reconcile our understanding of gravity with that of quantum mechanics, which explains how matter and energy behave on an atomic scale and below. Under quantum gravity, the physical nature that we know is not actually the fundamental reality. Instead, the fabric of space and time emerge from an underlying foundation, an abstract mathematical realm of pure information. In their study, Fazil and colleagues show that even in such information based Platonic realm, it is not possible to fully describe reality using computation alone. Now, that part I do understand. I don't know if it's going to change my mind. I think we're still living in the Matrix, but let's read on. The team point, for example, to mathematician Kurt Gödel's first incompleteness theorem, which states that no consistent system of axioms that can be listed by an algorithm that will prove all the truths about the arithmetic of the natural numbers. Instead, there will always be statements about natural numbers that are either true or false, but that are unprovable within the system in question. At least they dumbed it down a little bit. Gödel's first incompleteness theorem is related to, and in fact inspired by, the famous self-referencing liar's paradox of this statement is false. In a similar way, Gödel, however we're pronouncing his name, put together a mathematical statement that translates to this statement is unprovable, which is true, but inherently mathematically unprovable. In this way, there are Gödelian truths that rely on non-algorithmic understanding that would need to be included in any complete and consistent description of anything. Joined on mathematical theorems relating to incompleteness and definability, we demonstrate that a fully consistent and complete description of reality cannot be achieved through computation alone. That was said by Fazil. Any simulation is inherently algorithmic. It must follow programmed rules, he added. But since the fundamental level of reality is based on non algorithmic understanding, the universe cannot be and could never be a simulation. Beyond debunking many a good sci fi plot, the researchers say that their conclusion has profound implications for our understanding of physics. The fundamental laws of physics cannot be constrained within space and time because they generate them, explained the paper author and theoretical physicist Lawrence M. Krauss in a statement. It has long been hoped, however, that a truly fundamental theory of everything could eventually describe all physical phenomena through computations grounded in these laws. Yet we have demonstrated that is not possible. A complete and consistent description of reality requires something deeper. But yeah, now that I've read it out loud, I have to say that, yeah, it's probably true that, yeah, we're not in the Matrix. And to all of you that believed that we were, I'm sorry. Second read through definitely, yeah, I understood it a little bit better, but I'm going to post this and I will leave, I will try to leave a link in the description for you. So, yep, there you have it. The Matrix is not real. And like and subscribe and have a day.